G'day everybody, my name is Reese and this is my short video series where I show you how to do cool things in SPSS in less than 10 minutes. In this video, I will be showing you how to perform a one-way repeated measures ANOVA. The purpose of this video is to highlight what is unique about performing a repeated measures ANOVA over that of a normal between subjects design. If you need to cover those basic concepts of ANOVA, I would suggest you cover my between subjects ANOVA video because a lot of the core concepts are the same. This video only intends on highlighting the things which are different about the repeated measures design. Alright guys, I've now jumped into SPSS and I feel before that we actually perform our analysis in SPSS, it's probably good if we have an idea of what variables I'm using as an example today. So we're performing a one-way repeated measures ANOVA and I've got my data set up. It's not a real data set, I've just simulated some data for the purposes of this video. So in this particular mock data set, I've pretended that I've run a cognitive-based computer task where I have assessed people's response times to different word type. So I've got neutral words, negative words, and positive words. So you can pretend if you're a participant in this study, you would be placed in front of a computer and certain words would be flashed up on the screen and you'd have to respond to them in a given time. So there'd be neutral based words, negatively phrased words, and positively phrased words. Now in my later video on two-way repeated measures ANOVA, I'm going to make this data set a little bit more complicated by introducing a second variable called distraction. So I'm going to have distraction and no distraction. Today's video won't be as complicated, so you can just think of this as one IV, neutral, negative, and positive, but after you finish watching this video, you might like to check out the more advanced two-way repeated measures ANOVA, where I introduce distraction as a second independent variable. If I flick to the variable view very quickly, you can see neutral words, negative words, positive words, all set up. Now, if you've only analyzed between subjects variables in SPSS before, you would be used to columns representing different variables. However, in SPSS repeated measures designs, each column in SPSS now represents an individual level of one IV. So with my three columns here, I've actually only got one independent variable here, word type, spread across three columns representing each level of the IV. That is very different to a between subjects design where you only need one column to represent an independent variable. That's the key difference in how SPSS needs the data set up for repeated measures designs. In terms of the row structure here is consistent. So the rows here represent different participants. Now, once you've got over that initial hurdle of understanding how the data is set up, you're now ready to analyze your first repeated measures ANOVA. If you were to try to do this via general linear model univariate, you would very quickly realize that based on the way in which the data has been set up, with a different row and with a different column structure, than a between subjects design, you can no longer use that function. So we need to go to analyze, general linear model, and then repeated measures in this particular instance here. Now, at the first little screen here, SPSS wants you to name your independent variable, because so far I've only named the levels of the independent variable, positive, negative, and neutral. So I'm going to go ahead and type here word. You could call your variable word type or type, whatever you wanted, and it has three different levels. Hit add and then click define. Now, SPSS knows that there are three different levels for my IV, and it wants me to drag these across. Now, the order doesn't particularly matter unless you have an order that you have memorized, like maybe you had a repeated measures design with pre-test, post-test, or something like that, in which case you'd probably want to keep them in some sort of clear and concise order. Now, if I was to select OK, I would generate just my basic normal output. However, just to have a brief outline of what these different options are, a lot of them are very, very similar to that of between subjects ANOVA. We can custom fit models, we can custom fit different contrast tests as well. If you needed to fit any sort of special contrast or something which doesn't fit some sort of predefined set of contrast, you would need to use the syntax. We'll keep that complicated stuff for a later video. We've also got a plots button where you can do different plots. You can also do different post hoc tests if you have a mixed design. So if you have an additional independent variable that's a between subjects factor, you can place that there, in which case you can run a post hoc test on them. If you'll see here, you can't run post hocs for repeated measures factors, so there's nothing to actually click here. You can save different parts of your output. We'll leave that for now. And there are also options just like we have in normal general linear model univariate as well. Now, I won't touch a lot of these different options, but you can see they're mainly consistent. So you've got observed power, descriptive statistics, effect size, homogeneity tests, those sorts of things. I think the only one I'll turn on for the purposes of this video is I'll ask for some pairwise comparisons for our IV, and I'll also Bonferroni adjust my pairwise comparisons. Now, if you're wondering what Bonferroni adjustments are, I would suggest you do some theoretical reading on type 1 and type 2 errors for a deeper understanding of what I've just selected there. But for the purposes of this video being purely instructive on how to do a repeated measures ANOVA in SPSS, we can just leave the complexity side of type 1 errors for a later date. So I'm going to go ahead now, hit continue and then OK. And you can see here SPSS has generated my output for me. The first table here is giving me an idea about what the levels are of my independent variable. We already knew that, so it's neutral, negative, and positive. It's just giving you a bit of a reminder. Now, if I scroll down the output, you're going to see very different or unique output for an ANOVA if you've never done a repeated measures design before. Now, the first important thing to note, and something that you'll definitely need to do some in-depth reading on yourself, is the fact that there are two different approaches one can take for interpreting repeated measures output. The first approach, and by far the easier approach, is the multivariate test approach. Now, if you're performing a multivariate test, or if that's the approach you're taking to analyzing your data, it's simply a matter of assessing the significance of any number of these four tests here, most common being Pillai's, Trace, and Wilks lambda, and assessing the significance just like you would any other regular F ratio. So here the p-value is less than 0.001, so we can conclude that there's a significant mean difference in response time across the different word types. So if you take the multivariate test approach, analyzing the data is very similar to a between subjects design. Now, I'm not going through the theory here about what the multivariate test actually is. I will leave that for an in-depth read into a prescribed statistical test. But in terms of analyzing the output, it's as simple as reading the p-value. After which case you could do some post hoc tests in the form of some pairwise comparisons. Now, the pairwise comparisons in a repeated measures design are interpreted the exact same way that one would interpret pairwise comparisons in a between subjects design. The one key theoretical difference is the fact that the standard error terms are not fixed. They don't come from the same pooled error term that they would if it was a between subjects ANOVA design. Just a theoretical point to make, doesn't change our interpretation of the values, but it is something important to note. If you were taking the alternative approach, the traditional approach, actually the first approach that a lot of students are introduced to, you would need to get through an assumption of sphericity. So this is a brand new assumption for repeated measures designs. Now, the assumption of sphericity is quite complicated. It's similar to Levene's by definition, but it has a higher tier of difficulty to understand. Now, I don't often recommend this, but Wikipedia actually has a great explanation about what sphericity is if you wanted a deeper understanding of this assumption. In terms of an application point of view, you can interpret it in a similar way to Levene's test, in that you get a p-value for the assumption test, and you can assess whether the assumption has been met or not. So here the p-value is non-significant for Mulchleys, so we have not significantly violated this assumption. However, there are some people in the statistical community that argue that this test is not sensitive enough, so we've also got different adjustments that we can make based on this assumption called epsilon figures. There are different epsilon figures that one can adjust or use for adjustment purposes. The most common, however, is the greenhouse geyser. And a way to think of these different epsilon figures is This is a number here about the proportion in which this assumption has been met. So if this epsilon figure here was 1, that would mean that you've 100% met the assumption of sphericity. If you had a 0, that would mean you have completely not met the assumption. Now that interpretation isn't like strictly correct from like a mathematical point of view, but it helps in terms of interpretation, because what we see down here in terms of the interpretation of the F ratios, we get 4 different rows here. Sphericity assumed, that's the row that you would report and interpret if you were assuming that the assumption was met. And then you've got 3 other different rows here, starting with the greenhouse geyser row, the most common, where the degrees of freedom are punished or made smaller based on the proportion in which your epsilon figure perceives the severity of the violation in sphericity. So this 0.776 here, if I was to multiply my word type degrees of freedom here of 2, multiply it by 0.776, that would reduce my degrees of freedom by 1.55. Now, what a reduction in degrees of freedom actually does is it changes the critical value of our F value in terms of what we would deem as being significant or not. Now, SPSS makes these adjustments for us. So from an interpretation point of view, it's simply a matter of choosing, am I going to assume that sphericity has been met, or am I going to adjust using something like a greenhouse geyser and reporting the statistics on the row below it? Now, the choice between assuming sphericity is met in greenhouse or greenhouse geyser adjustment should be made is something that needs to be argued, and I suggest that you consult with your prescribed text for deeper information on that. Irrespective of what decision we made here, whether we were to assume that sphericity is met or whether we adjusted via the greenhouse geyser adjustment, we would still reach the same conclusion that there is a significant mean difference across word type on our response times. And after the traditional approach, you can then go ahead and perform pairwise comparisons just like you could have done if you were adopting the multivariate test approach. So you can see here that the repeated measures output looks quite different to between subjects designs, but the interpretation doesn't really change much. We still get F ratios, we still get 2 degrees of freedom, which we would have to report, so one for our IV, one for our error term, and we still have some sort of follow-up test that we can do in the form of pairwise comparisons, or perhaps if you had planned a priori hypotheses, you could fit them in the same way that you do for a between subjects design. The key thing to understand about repeated measures designs are the things which make it different from between subjects. So in terms of SPSS, that means how the data looks in the data file, and then being able to understand that you've got 2 different ways to analyze your data, the multivariate test approach and the traditional test approach. Just one small thing to note, there are some pieces of output here which are not relevant if you're just performing a one-way repeated measures design. So I didn't do any contrast test here. I wasn't interested in performing any contrast, but they are given to you by default. So you can just simply ignore the contrast if you don't need them. If you haven't got an additional IV, which is a between subjects variable, which would make this design a mixed design, this table is also not important because there's no IV to present here, so you're just given the intercept and the error term, so it's the most useless table you could possibly imagine. Also, you get a second printout of the multivariate test approach right down the bottom, which is just identical to the one that you were given on the top. So when you're first becoming accustomed to reading output in the one-way repeated measures output view, you need to get used to being able to identify the multivariate test approach, the traditional approach, and then if you're doing any pairwise comparisons, where they are, and then whatever output that you don't specifically need, you just need to pretend that it's not even there. That'll make your life as simple and as easy as possible. And that's essentially it for a one-way repeated measures design, guys. If you can analyze between subjects designs and interpret F ratios, you're perfectly capable of performing your own one-way repeated measures ANOVA in SPSS. Alright guys, that wraps up our short video today on one-way repeated measures ANOVA. I hope it has been able to show you the finer points of performing this analysis in SPSS and has given you a bit of a head start on how to interpret the output. Please note this video was just an introduction to this design, and I strongly recommend you consult with your prescribed text for the finer details of this model. Cheers guys, I'll catch you next time.